All right, so we did 3-1, which was graphing. Okay, so that's one of the methods that we have to solving a systems of equations is graphing. We have 4 more to get through. Today we're going to hit up substitution. So what I would like you to do now is I would like you to try and draw on some of your prior information because you saw solving systems of equations by substitution in Algebra 1. You saw it in Algebra 2. You might have even seen it in some of your geometry classes too. Okay? So it's out there. I want to see what you remember, and then we'll go through it. Okay? So solve that system using substitution and only substitution. Okay? All right. So what do we do first in substitution?
For the right equation, I put y equal to everything.
So you solved the right equation for y?
Yeah.
Okay. All right. So you added 2x here. You added 2x there. So then that gave you y equals 2x plus 4. Or 4 plus 2x, however you wanted to write it. Okay. I like that for a first step. Okay. Now what?
Isolate the x in the red equation.
Don't have to.
Well, then you just put in y for the, so it'd be like 2 times y, or 2 times 2x plus 4.
So I take this, and I bring this over here, and I put it in there for y. Okay? I'm swapping out y for 2x plus 4. Yep. Okay? So then that would become 3x plus 2, and then now the y is 2x plus 4, and then that's going to equal 1. Okay? Now what? Right? Solve for x. Okay? So that's going to be 3x plus 4x plus 8 equals 1. 7x plus 8 equals 1. Subtracting 8. (7x) equals -7. Dividing by 7. X equals -1. So I'm going to take this then, and I'm going to put it where? Back in there, right? Okay. So then this would be y equals 2 times -1 plus 4. So that's going to be -2 plus 4. So then y is going to equal 2. Now what? 2 times -1 is plus 4. Okay. 2 in my world. Okay. Now what? Okay. Check them both. So 3 times -1 is -3. Plus 2 times 2 is 4. So -3 plus 4 is +1. Checks out in the red. -2 times -1 is +2. Plus 2 is 4. 4 is equal to 4. Works out in blue. So now what? Think back to graphing. Now what? Okay? Now it's a point, but what are the coordinates of that point? Noah?
-1, 0 for the x.
No.
-1,
-1 comma 2 is the point.
That's right.
Okay? Alright? Let's put those steps into a little bit more writing. Okay? So the strategy that we use for solving by substitution is, first off, what do? What do we do first? Do I have to solve for what? So I pick one of the equations and I solve for one of the variables. Okay? So I solve for one lone variable. Now, make it easy on yourselves. Okay? What I mean by that is, if I go back to this equation, I probably wouldn't solve the red equation for x, because I'd have to divide by 3. And what am I going to get? Fractions. Okay? So make it easy on yourself. You guys actually picked the right one. Okay? The easiest variable to solve for in between red and blue is blue y. Okay? So make it easy on yourselves. Don't work smarter, not harder. Okay? Alright? So we solve for one variable between the 4. Okay? Then what? Substitute it back into the other equation. Okay? Then what? Then we... Not yet. One step too ahead. We solved. Yep. We got to solve that equation. Okay? Then we put it back, and then we replace it again to get the other variable. And then what did we do at the end? We did two things at the end. We did two things at the very end. What did we do? We checked our answer. And we put it in point form, right? Okay. Now, I'm telling you this. We are solving, in this chapter, we're solving systems of equations. Okay? So, on every homework, on every formative assessment, Wednesday, this week and next week, on every quiz, this week, Friday, on every test, the 17th of February, okay? You should know 30 to 45 seconds after that problem if you got it right or not. So that when you're done with that, you should know, yep, I'm done. I aced this thing. Okay? You should know that stuff if you do the check. Am I saying you have to do the check? No. Okay? But if it were up to me, if I had the choice between not knowing if I got 100% and knowing for sure that I got 100%, which one do you think I'd take? I take the 100% every day of the week and twice on Sundays. Okay? Or I take knowing that I got 100% of the time. Yeah? Okay? Alright? So, I'm not saying you have to do the check. But, oh man, just the ease, just the lack of stress of, yeah, I did it right. I just checked it. Boom. You know what I mean? The old, what's it, the old, Scottish actor? Sean Connery, yeah. The old Sean Connery from that's good. That's good. The old Sean Connery from Saturday Night Live parodies of Jeopardy. Suck it, Trebek. You know what I mean? Okay? You can say that to every problem because you're gonna knock these out of the park. Because you're gonna know if you screwed up or not. Okay? And so what happens if you check and you get an answer wrong? Go back and redo it. But still, I'd rather go back and redo it than wait on me to correct it. You know what I mean? Okay? Boom! Do it, man. Do it! Which equation, which variable? Which equation? Left or right? Right. Which variable? X. The right x is the easy one to solve for. Okay? Again, make it easy on yourself. If you didn't choose that, keep going. You'll be fine. Okay? So here this would be x equals -9 minus 5y. Or if you wanted to go -5y minus 9, that's fine too. Okay? So then we take that and we plug that in for x. -36 minus 20y plus 3y equals -2. So -36 minus 17y is equal to -2. -17y is equal to 34. So I get y is equal to -2. Take that, then, back up there. So x is equal to -9 minus 5 times -2, so that's going to be -9 plus 10, so that's going to be x is +1, so that gives me a point of 1 comma -2. Checking it, 1 times 4 is 4, 3 times -2 is -6, 4 plus -6 is -2. 1 is 1. -2 times 5 is -10. 1 plus -10 is -9. There's that one. Okay? Okay? Questions on that one? It'd be no different if I went from 6, 7 x plus 3y equals -34. 0.5x minus 0.25y equals -0.5. You know what I mean? Decimals are fractions. You know what's up?
Where is this like real world at? I can't say that's real.
If you have a function, so we're talking about intersecting functions.
Yeah.
You know what I mean? So if you can model a function or model something, like I could model, let's say in the teaching world, okay? if I have this many hours of or minutes of instruction, you know, grade should go. You know what I mean? But if I have, you know, this, you know, so I look for the intersection points.
And this just has like 2 variables per line. Like when would that be used?
You can use it. Lots of stuff gets modeled with 2 variables.
Okay.
Yeah. You know, distance and time.
Okay.
You know, number of reams of paper produced per hour at a paper mill. You know? Yeah. Okay. So, how are we going to tackle this? Do you like fractions? Okay. Can we just get rid of both of the fractions, or can we get rid of all the fractions first? Okay. Okay. So if I got rid of all of the fractions first, I would multiply this whole equation by what? The top one. Multiply it by 3. Okay. Now, when I do that, I've got to multiply in that 3 everywhere. So that gives me 2x plus 9y equals negative 102. What would you multiply the bottom equation by? 4. Again, everywhere. So then that gives us 2x minus y equals negative 2. You handle it from there now? Okay, same equations, just wrote them in a different way. Solve it using substitution. So I would solve the bottom equation for y, and I would get 2x plus 2 is equal to y. Then I'm going to take that, and I'm going to plug that in for y into the other equation. So 2x plus 9 times 2x plus 2 is equal to negative 102. 2x plus 18x plus 18 is negative 102. 20x plus 18 is negative 102. Subtract 18 from both sides. 20x is equal to negative 120. Divide by 20. X then is negative 6. So I'm going to take that and I'm going to put that up into there. So then y is going to be 2 times negative 6 plus 2. So that's going to be negative 12 plus 2, which is going to be negative 10. So I get a tentative answer of negative 6, comma, negative 10. Where should I check that answer? In my original equations, right? Okay. Always check back in your original equations. So 2/3 times negative 6 is negative 4. 3 times negative 10 is negative 30. Negative 4 plus negative 30 is negative 34. Checks out in the first one. Okay? 1/2 times negative 6 is negative 3. 1/4 times negative 10 is negative 5/2. Negative 3 minus negative 5/2 is like negative 3 plus 5/2 is negative 1/2. Negative 1/2 is equal to negative 1/2. So there's my answer. Okay? Now, we have two special situations in substitution, just like we had two special situations in graphing. Okay? The first one is going to deal with something, and the second one's going to deal with another thing too. So, let's do situation number 1 first. Okay? I need a variable and an equation. So top or bottom, x and y. What do you want to solve for? Which one do you want to isolate? Top one for y or top one for x? I don't care. X? Because it's smaller? Doesn't really matter because there's no easy one to pick, right? Okay? So you guys are going top one for x, you said? Okay? So then that would be 3x equals 6y plus 14. Agree? Divide everything by 3. X equals 2y plus 14/3. Yes? Take that, put that into the bottom equation. Negative 6 times 2y plus 14/3 plus 12y equals negative 16. Negative 12y plus, nope, that shouldn't be plus, it's going to be negative. Oh, tap the brakes. Big old eraser. Negative 6 divided by 3. Negative 2 times 14. Negative 28. So then here I get negative 28 equals negative 16. What's wrong with that? There's no variable and it's not true. It's false. So that's a false statement with no variables. So can there be a solution? No. So that's my answer. My answer is no solution.
And do we only have to check that one equation?
What I recommend here in this case, Trent, is I would recommend you go back and kind of quote unquote redo the problem by picking another variable. Okay? So another one of the three, go through it, solve for it, plug it back in, just to make sure. Because I always say, well, go back up and check your work. But if you made the mistake 45 seconds ago, you're probably going to make the mistake again. You know what I mean? But if you choose a different variable, then you can probably not make the same mistake. Okay? All right, so let's go to situation number 2 then. Pick a variable. Pick an equation. X on top again. So then that would be 2x equals 4y plus 13. So then x would be 2y plus 13 halves. Yes? So then negative 4y, oops, I put equals, that shouldn't be equals. Negative 4y minus 13 plus 4y equals negative 13. So negative 13 equals negative 13. What do we got here for this special situation? Infinite solutions, okay? Because we have a true statement now, with no variables. So that one's infinite solutions. Leslie?
If you go up a little bit, the original problem, it looks like it's the exact opposite. Like it's the equation, like the positives are negatives and negatives are positives. Positives. Is that gonna happen every time the infinite solution? You know, like that?
Not necessarily, because I could have written the top equation. If I just look at the top one, I could have wrote that as 6x minus 12y equals 39.
Okay.
You know what I mean? And it still would have given me infinite solution. Okay. So again, you already have these written down, but if the variables cancel and it's a true sentence or true statement, that's infinite solutions. If the variables cancel and it's false, it's no solution. Okay? Otherwise, your answer. So now we have, just like when we were graphing, we have our 3 types of answers. If they intersect at a point, we give that point. If they don't intersect, it's no solutions. If they end up being the same line, it's infinite solutions. Okay? I took the 3.2 homework and I broke it up into 2 days. So this is day number 1. Okay? Page 164 to 160. I think you only really have to go up to 165 is what they were saying in the last class. But it's 7 through 13 odds, 47 and 55. So that's a grand total of 6 problems. Okay? Due tomorrow.